In today's video, you will learn how to find angle measures using angle relationships. We will start by recalling the different types of angles. It will be followed by the different angle pairs and their relationships, and then we will deal with triangle sum theorem. Towards the end, I will walk you through in answering sample problems on the topic to check your understanding of the concepts and to let you experience how these are analyzed and solved so that you will be able to successfully answer geometry problems similar to this in the future. If your lesson is on finding angle measures using their relationships, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Let us recall what an angle is. On a previous video, we defined an angle as a figure formed by two rays, its sides, sharing a common endpoint called the vertex of the angle. The measure of the angle is the radial distance between two rays or sides, shown by the arc here. A protractor is used to physically measure the size of an angle. Here, we will learn how to get the measure of the angles by using angle relationships. Throughout the video, we will use the degree unit for angle measure. I am sure that you have worked on the different types of angles in your previous math subjects, but we will look at them again to refresh your memories. The table that follows displays the different types of angles and facts about them. The first one, acute angle, an angle whose measure is less than 90 degrees. Right angle, an angle whose measure is 90 degrees. Obtuse angle, an angle whose measure is greater than 90 degrees but less than 180 degrees. Straight angle, an angle whose measure is 180 degrees. The corresponding drawings are presented here as well. You must also recall that there are several ways of naming an angle. One way is by using 3 points on the angle, 2 coming from the two sides, and the middle point, the vertex. So we can name the angle here as angle ANH. Another way is by using the vertex point. The same angle can also be named as angle N. If a lowercase letter or a number is written inside the angle as what we have here, we can name the same angle as angle 2. Having recalled the different types of angles and how they are named, we will now move on to the different angle pairs and their relationships. Let us look at them one by one. First, adjacent angles. Adjacent angles are angles sharing a common side and vertex. Here, we say angle NFD is adjacent to angle DFC, or we simply say angle NFD and angle DFC are adjacent angles. If the angles are labeled using numbers like this, we can also write this. Angle 1 and angle 2 are adjacent angles. Here, we are referring to the same angles we named earlier. Going forward, we will be labeling angles using numbers for ease. Second, linear pair. These are two adjacent angles whose non-common side forms a straight line. Here, angle 3 and angle 4 are linear pair. The sum of the measures of the two angles is 180 degrees. That is, the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Thus, if one angle has a measure of 135 degrees, then the other must be 45 degrees as shown. Third, complementary angles. The sum of the measures of these two angles is 90 degrees. They may be placed so that they form perpendicular lines like this, or they may be two separate angles as shown. Always remember that for this type of angle pair, the sum of the measures of the two is 90 degrees. We can write it this way. The measure of angle 5 plus the measure of angle 6 equals 90 degrees. Thus, if the measure of angle 5 is 60 degrees, then the measure of angle 6 is 30 degrees. Fourth, supplementary angles. The sum of the measures of these two angles is 180 degrees. They may be placed so that they form a linear pair like this, or they may be two separate angles as shown. Again, remember that the sum of the measures of these two angles is 180 degrees. That is, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So if one angle measures 60 degrees, then the other must have a measure of 120 degrees. Fifth, vertical angles. These are the angles formed by pairs of opposite rays. Oftentimes, we describe them as angles formed by two intersecting lines. One fact about this type of angle pair is that they are congruent. This pair are congruent, and this pair are congruent. When two lines intersect, there are other types of angle pairs that are created aside from the vertical angles. Let's name the angles formed by the intersecting lines here. Do you recognize the angle pairs that are here? Okay, angle 1 and angle 2 are adjacent angles. They're also a linear pair. At the same time, angle 1 and angle 2 are supplementary. The sum of the measure of these two angles is 180 degrees. Can you follow, learners? The same with angle 3 and angle 2, with angle 3 and angle 4, and with angle 4 and angle 1. On the other hand, angle 1 and angle 3 are vertical angles and are congruent. The same with angle 4 and angle 2. Now let us look at this triangle. How many angles inside the triangle are there? Right, there are 3 interior angles, and each angle has its own measure. But the sum of these 3 is always 180 degrees, no matter what type of triangle it is. Check this triangle that we have here. The sum of the angles inside each triangle is 180 degrees. These can be represented mathematically this way. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. This is the Triangle Sum Theorem, where angle 1, angle 2, and angle 3 are the interior angles of a triangle. Look at this triangle, learners. We will extend some of its sides like this. What do you observe this time? Okay, so extending the sides of a triangle creates different types of angle pairs. Recognizing the types of angle pairs together with the relationships and the Triangle Sum Theorem will help you solve a lot of math problems with ease. Let us look at these angles here. Here, we have several linear pairs, like angle 5 and angle 6, angle 4 and angle 1, angle 6 and angle 2, and angle 3 and angle 7. These angles are supplementary and adjacent as well. For this type of angles, the sum of the measures of each pair is 180 degrees. Another angle pair that you can find here are vertical angles like angle 5 and angle 2. An important thing to remember about this pair is that they are congruent. So if one measures 60 degrees, the other one also measures 60 degrees. With those learning, we can now try answering the sample problem that follow. Let us begin with sample problem 1. Here's the problem. Consider the figure below. What is the measure of angle X? Option A, 60 degrees. Option B, 80 degrees. Option C, 70 degrees. Option D, 90 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for, her learners? You are right. We are to find the measure of angle X. What are we given here? We're given a figure with some angle measures. Okay, so we analyze the figure and locate where angle X is, the angle whose measure we want to find. From where angle X is, we can see that we need the measures of the other angles to get the measure of angle X, right? To make our work easier, we will modify the figure by giving names to the angles inside the triangle. So we have angle 1, angle 2, and angle 3 inside the triangle. Look at the figure again this time. To get the measure of angle X, we need the measure of angle 3. Do you agree? But to get the measure of angle 3, we need to know the measure of angle 1 and angle 2, right? Now, we know where to start. We start by determining the measure of angle 1, then get the measure of angle 2, then get the measure of angle 3, and finally, get the measure of angle X. Were you able to follow, learners? Okay, so we begin by finding the value of angle 1. Look at the part of the triangle where angle 1 is. Next to it is an angle with a measure of 120 degrees. What type of angle pair do they form? Right, linear pair. Recall that the pair add up to 180 degrees. That being said, we can get the measure of angle 1, right? Now, what number when added to 120 gives 180? You are right, 60. So angle 1 is 60 degrees. We do the same with angle 2. The angle with a measure of 130 degrees and angle 2 is a linear pair. So their sum is also 180 degrees. What number when added to 130 gives 180? You are correct, 50. So angle 2 is 50 degrees. Look at the figure again, learners. We now know two angle measures inside the triangle. How can we solve for angle 3 this time? You are correct. We will use Triangle Sum Theorem, which states that the sum of the three interior angles in a triangle is 180 degrees. So, what is the measure of angle 3? That is, what number, when added to 60 and 50, will give you 180? You are correct. It is 70. So, angle 3 is 70 degrees. There you are, learners. Look at the figure again. How can we now get the value of X? What type of angles are angle X and the one with a measure of 70 degrees? You are correct. They are vertical angles. And what do we know about them? They are congruent. There you are. So what is the measure of angle X? Is it option A? Option B? Option C? Or option D? Perfect. It is option C. The measure of angle X is 70 degrees. There you are, learners. We have answered the problem. Okay, so we move on to sample problem 2. Here's the problem. Consider the figure below. Which of the following is the measure of angle X? A, 40 degrees. Option B, 65 degrees. C, 115 degrees. And option D, 140 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information helps find what we are looking for. What are we looking for, her learners? You are right. We're looking for the measure of angle x. What are we given here? A figure is given with some angle measures. Okay, we will look at the figure and determine an action on how to find the value of angle x. We start from where angle x is located. By inspection, we know that we need the measure of other angles to determine the measure of angle x. As in the first sample problem, we will name the other angles inside the triangle whose values are not known to make our work easier. Let's go. Here is now the modified version of our figure. So the angle adjacent to angle x is angle 2. With that, can we now get the value of angle x? No, not yet, because we do not know the measure of angle 2. How can we get the measure of angle 2 then? You are right. We can get it by first getting the value of angle 1. Can we get the value of angle 1? Yes, because angle 1 form a linear pair with a given angle whose measure is 115. Knowing that the sum of their angle is 180, we can solve for the measure of angle 1. What number, when added to 115, gives 180? You are correct, 65. So, angle 1 is 65 degrees. Look at the figure again. Of the 3 interior angles inside the triangle, how many are now known? Right, we already know the measure of 2 angles. Can we now solve for the measure of angle 2? And how? Yes, we can now get the measure of angle 2 by using Triangle Sum Theorem. So, what number, when added to 75 and 65, gives 180? There you are, it is 40. So the measure of angle 2 is 40 degrees. Can we now get the value of x? What type of angles are angle x and the angle with a measure of 40 degrees? You are correct, linear pair. And what do we know about them? Right, their sum is 180 degrees. So, what number, when added to 40, gives 180? There you are, it is 140. So, the measure of angle x is 140 degrees. So, what is the answer? Right, option D is the answer. There you are, learners. We're done with this problem. Let us move on to sample problem 3. Here's the problem. In the figure below, the measure of angle 1 equals 5x plus 10. The measure of angle 2 equals 9x plus 2. And the measure of angle 5 equals 90 minus 5x. What is the value of x and the measure of angle 4? Option A, x equals 12 and the measure of angle 4 is 70 degrees. Option B, x equals 14 and the measure of angle 4 is 80 degrees. Option C, x equals 12 and the measure of angle 4 is 80 degrees. Option D, x equals 14 and the measure of angle 4 is 70 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information helps find what we are looking for. What are we looking for, learners? You're right. We are to determine 2 things here. First, we are to find the value of the variable x. Second, we are to get the measure of angle 4. What are we given here? A figure is given with the expression containing variable x for the measure of angle 1, the measure of angle 2, and the measure of angle 5. Let us examine the figure carefully and determine the relationships that exist between the angles. Okay, so angle 1 and angle 2 form a linear pair, right? What did we say about the sum of the angles of the two? Correct, the sum is 180 degrees. Here's again the relation in equation form. That is, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Angle 2 and angle 3 are likewise a linear pair, so they will have the same relationship. What about angle 1 and angle 3? How are they related? Right, they are vertical angles and they are congruent. In equation form, we write it this way. The measure of angle 1 is equal to the measure of angle 3. On the other hand, angle 3, angle 4, and angle 5 are interior angles of the triangle. And the sum of their angles is 180 degrees. Or we say the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 equals 180 degrees. These relationships, together with the given expressions for the measure of angle 1, the measure of angle 2, and the measure of angle 5, will help us determine the value of x and the measure of angle 4. Since we won't be able to get the measure of the angle without the value of x, determining the value of x will be the first thing that we will do. Now, which angles on the figure with the variable expressions are related? Right, angle 1 and angle 2. Earlier we said that these two form a linear pair and are related by this equation. The measure of angle 1 plus the measure of angle 2 equals 180. Substituting the values for the measure of angle 1 and the measure of angle 2 into the equation, we have 5x plus 10 plus 9x plus 2 equals 180. Combining like terms gives us this. 14x plus 12 equals 180. Subtracting 12 from both sides of the equation gives us this. 14x equals 168. Now, dividing both sides by 14 gives us the value of x, which is 12. Since we now have the value of x, we can now determine the measure of the angles containing the variable x. Let us go and look at the figure again. Remember that angle 4 is inside the triangle. So, for us to be able to get its measure, we need to know first the measures of the two other angles, angle 3 and angle 5. Where do we start here? Look at angle 3. It is related to both angles outside of the triangle. With angle 2, they form a linear pair. With angle 1, they are vertical with each other. So, you can choose which one to use. Okay, we will use angle 1. For us to know the measure of angle 3, we need to know the measure of angle 1. To get the measure of angle 1, we need to plug in the value of x we obtained earlier. We start with what is given, the measure of angle 1 containing variable x, which is 5x plus 10. We plug in the value of x, so we have 5 times 12 plus 10. Multiplying 5 and 12, we have 60 plus 10. Adding 60 and 10 gives us the measure of angle 1. So the measure of angle 1 is 70 degrees. Now look at the figure again. What type of angle pair are angle 1 and angle 3? Right, they're vertical angles. What do we know about their angle measures? They are congruent. So what is now the measure of angle 3? The measure of angle 3 is also 70 degrees. Now remember that we need to know two angle measures of the three angles inside the triangle to find the third one. So next, we need to determine the measure of angle 5. To do that, we again substitute the value of x we got earlier into the given measure of angle 5, which is the measure of angle 5 equals 90 minus 5x. We plug in the value of x. We have 90 minus 5 times 12. Multiplying 5 and 12, we have 90 minus 60. Subtracting 60 from 90, we have 30. Thus, the measure of angle 5 is 30 degrees. Look at the drawing again. Inside the triangle, we already have two angle measures. Can we now solve for the measure of angle 4? How? Right, by using Triangle Sum Theorem. So, what is the number which, when added to 70 and 30, will give you 180? Right, it is 80 degrees, so the measure of angle 4 is 80 degrees. Let us now answer the problem. What is the value of x and the measure of angle 4? Is it option A? Option B? Or is it option C? Or option D? There you are, learners. The answer is option C. We are done with the problem. Hopefully, you got lots of learning on this video. There you are, learners. Let us summarize what we have learned in today's video. We have learned that, first, an angle is a figure formed by two rays sharing a common endpoint called the vertex. Second, the different types of angles with their descriptions are as follows. Acute angle, an angle whose measure is less than 90 degrees. Right angle, an angle whose measure is 90 degrees. Obtuse angle, an angle whose measure is greater than 90 degrees but less than 180 degrees. Straight angle, an angle whose measure is 180 degrees. Their corresponding drawings are on the table. Third, adjacent angles are angles sharing a common side and vertex. Fourth, linear pair are two adjacent angles whose non-common side forms a straight line. The sum of the measures of the two angles is 180 degrees. Fifth, complementary angles are two angles with sum of their measures equals 90 degrees. The pair may be placed so that they form perpendicular lines, or they may be separate angles. Sixth, supplementary angles are two angles with sum of their measures equals 180 degrees. They may be placed so that they form a linear pair, or they may be two separate angles. Seventh, vertical angles are angles formed by pair of opposite rays or by two intersecting lines. Vertical angles are congruent. Eighth, Triangle Sum Theorem states that the sum of all the interior angles of a triangle is 180 degrees. That is, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees, where angle 1, angle 2, and angle 3 are the interior angles of the triangle. Ninth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what information are given, and to figure out how the given information help solve the problem. 10th, when a figure is given, make use of it and modify when needed. It is there to help you analyze the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below, and do not forget to like, subscribe, and share this video to your peers so others will